So we're going to be doing 2 more FRQs, and this is just like a last minute practice for the AP test on Tuesday. So, I feel like at this point, all of you guys are like, you've done enough FRQs that anything you get, like you'll at least get half the points, which means you'll pass for sure. So at least be more confident in that. And I'm pretty sure you guys will get more than half. So just don't worry about that. Like if I do have to predict something though, like they are gonna put like a hard question. Like they have to. So like try to focus on those easy ones and make sure you're like perfect in that. And then if they give like a hard, and I feel like it's gonna be a theorem. It's gonna ask you to use a theorem in a weird way. And that's like what's gonna be hard about it. But if you have like the easy stuff down packed or like the regular stuff that we've been doing like over and over again, you guys will pass with 4s and 5s, I'm sure. So
Stop giving us hope. False hope.
no, I think so. I think we'll be good. So let's do the 2020 FRQ practice problem AB1.
Can we try it?
Can we what?
Can we try it?
If you guys want, I mean,
You guys
like, I think the best way would have, if you wanted to try it, you could have done it before the session, but I mean,
okay.
Not to be shady, but you guys can tell me what you think the answer is, and then I'll tell you. But you have to like respond to me when I call on you, okay? So let's read the problem. And this problem is like, it combines like regular functions and with also velocity. So it says the function f is defined on the closed interval from -3 to 12. The graph of f shown in the figure above consists of 3 line segments in a semicircle centered at 10, 0. Let g be the function defined by g of x, and that's what it is. For 0 to 12 seconds, a particle moves along the horizontal axis. At time t, the velocity v of the particle can be modeled by v of f of t. So that graph is pretty much, the graph can help you find g, and it can also help you find the velocity. And it says where f is given in the figure above, where v of t is measured in meters per second, and t is measured in seconds.
Wait, when it says v of t is equal to f of t, does that mean that v of t is equal to the graph?
Yes, that's exactly what it means. Okay. V of t is the graph. Isabella, we're just doing the first FRQ, so you didn't miss that much. So just we just started reading it. So let's go to the first part. A is the speed of the particle. A is the speed of the particle increasing or decreasing at t is equal to 5. Give a reason for your answer. Okay, Julia, since you wanted to like work with me with this, how would you do this problem? Julia?
Yeah.
How would you do it?
I don't know.
Okay. There's actually 2 ways to do this. But it really depends on how you see it. So the first thing I want to write is that always remember that at least in Cal, speed is equal to the absolute value of velocity. Okay. That's like the one thing that you should get across, and it's like that's like a formula. So since the graph is velocity, in order to get speed, speed would just have to be equal to the absolute value velocity, which is, as we know, right there. And it's pretty much this graph. So really, in order for you to tell if it's increasing or decreasing, one simple way to do this is just graph, like this graph, just in terms of absolute value, which absolute value, all it does is make everything positive. So all you'd have to do is like kind of sketch like a rough design, like here, it has like points here, but then everything just becomes positive. So that little part here, for example, it's like this. This stays positive. That little triangle here, it comes up here. That little circle there, it goes up there. And if you look at 5, which is like this line segment right here, it kind of coincides with this right here. 5 is like around here. Would you say that the speed is increasing or decreasing? Well, it's going up. So by that logic and by this little graph that we drew, the speed is increasing at t is equal to 5. That's one way to do it, if that makes sense to you guys.
I'm confused.
How come?
Like, okay, okay. For starters, speed is always the absolute value of velocity.
Yes, that's what speed is.
Okay, and then that graph. What
Yes.
is that graph?
Wait, say it again.
What's that graph? Where did you get that graph? What did you do to like draw? What did you do?
So here, let me erase this little part here because that's kind of confusing. So the graph is basically just, okay, we know that v, the velocity, is f. So I'm just gonna say f from now on, okay? The speed would just be the absolute value of f because that's what velocity is. And absolute value just means everything is positive, right? Everything is always just gonna be positive. So like this little segment right here, you would cross it out and make it like the opposite because that's negative and we're making it positive. Here, this little triangle right here, it's negative, so we would just make it positive. It's not to scale, but that's the idea. This little circle right here, it's negative, so we make it positive. Does that make sense?
Oh yeah.
That makes sense?
Yeah.
Okay, and that's like one way to see it, like if you forget the rule. And just remember that speed is absolute value of velocity. If you're given that graph, all you have to do is graph it in this way, show that you know what you're talking about, like within the graph. And since it's clearly increasing, like in this little segment where 5 is, then you can just say, by this logic, the speed is increasing, like by the graph, So like kind of draw attention to that. And since we're all going to be doing this like paper, pencil, I don't think any of you guys are typing it, you can draw a graph. Like, and it doesn't have to be perfect at all. It's just like a rough little sketch. Would just bring attention to 5. And
Wait,
Natalie, say that again?
would you need to draw the graph as evidence for this, or could you just say that the speed is
Yes, you would need to draw the graph. Only because like it shows like you can do it in your head. And like if you don't draw it, like yeah, you did it in your head, but like you didn't do the evidence. And if you don't want to draw the whole graph, if anything, just like draw like a little segment, like this little box right here, just so that you know what you're talking about. But yeah, I mean, again, it just has to be like a little sketch. They're not picky about that. But the other way to do this problem, which is kind of how Miss Q taught us, is so just have these both ways, figure out which way you like more. I think that they're both kind of simple, but it just depends on how you see it. I saw it this way first, but there's another way to do it. So basically,
So,
say that again. You guys kind of broke up.
okay, I have a question. So, is t increasing only because it's on the positive side of the graph, or it's because when you did the absolute value graph, it's going this way?
Well, the speed would be increasing because when we did the absolute value, it's going up at that point. That's kind of the logic behind it.
Would have
So
been at like t equals 7, where the line is going down, it would have been decreasing.
yeah, exactly. So just like make your assumption or make your declaration based on what your new graph looks like. Kind of ignore the old one and then use the new one, just in that regard. So the other way to do this problem, speed can be determined if the velocity and the acceleration, based on the velocity and the acceleration. So a rule is that if v of t and a of t, if they have the same sign, speed is increasing. And it doesn't have to be 2 pluses. It can be 2 minuses. Speed will be increasing. But if they have opposite signs, then speed would be decreasing. And that's another way to check. So what I'm going to do for this is just find the speed and the acceleration of this graph at 5, because it's very specific out t is equal to 5. And then from there, we'll just determine whether or not it's increasing, which we already know it is increasing based on our first way of doing the problem. But this will help us clarify another method. So v of t, as we know, is just f. So it's v of t is equal to f of t. So v of 5 would be f of 5. So v of 5 must be, and that's -1. A of t is v prime of t, which means that it's f prime of t. So a of 5 must be f prime of 5. Now, whenever you have a graph and it's asking you to take the derivative, but like it's just there's no function, you just have to kind of take the derivative of the like little segment, which is this. Since 5 is here, so we're just gonna take the slope of this line, because remember, derivative is slope. So I'm not gonna do the y2 minus y1 only because I see it goes -1, 1, -1, 1, -1, 1. So it's -1 over 1, which is just -1. So a of 5 is -1. And this goes to show that since even though the two have negative signs, the speed must be increasing because, as I said, they have the same sign. So all you would have to say is the speed is increasing at t is equal to 5 since v of 5 and a of 5, that came up with like an 8, have the same sign. And that's 2 ways to do this problem, because really it's important to know both, because in one case they may not give you the graph, but in another they may do it, and it may be very hard to tell like which point it's at. So just do whichever way is easier for you. I hope that they give like there's a way to do both, only because like you should have the freedom of choice. But at least if you know both, you can choose a solution based on the problem you get. And I do feel like they would give a velocity position problem only because that's more centered in like logic and like math, like the calculus concepts, rather than just like plugging in numbers. So I think that would be a very reasonable problem for them to give. Does that make sense? No questions? No? All right. So let's do part B. This is not going to be on the test, only because I know that one thing that you need to know won't be on the test is any basically it's what is known as AVT. So which is acceleration, velocity, and then oops, it's not PT, it's P. AVP. It's acceleration, velocity, and position for integrals, but that isn't going to be covered this year. But just so we can go over what this means, just because you know it's really important, a really important concept nonetheless. So it says find that integral from 0 to 12 of the absolute value of velocity. And then it also says to interpret what this means. So does anyone remember what this formula means, at least in a problem? Natalie, Kate.
What up? I'm thinking.
Starts with a T.
Well, the absolute value of velocity is speed, and then the integral of speed is
The integral.
Well, the answer pretty much is, if you remember, any integral with absolute value velocity is the total distance. And don't confuse it with like actual distance traveled, because remember that velocity has directions. Speed is just always positive. So in order to explain that better, if your graph kind of goes like this in this image, like it goes like that, this is the x-axis. This is a distance altogether, but then this is a negative distance. So like you're going back, essentially. You're turning directions. But that doesn't mean that you're still not traveling. So by taking the absolute value, you're just making sure that you're accounting for this distance here that is negative, essentially, but it's still like real miles that you're traveling. So you need to include that. That's what the absolute value does. So, and there's another problem I picked out that kind of more relates to that concept. It's a very like more like thinking problem based on velocity. So we'll get to that later. So basically just know that that formula is the total distance. So how do we find this? Oops, how do we find that? And it actually just kind of relates to the little graph that we drew earlier. Remember that when we're doing this, and if you need to visualize it, basically, and I'm just gonna draw from 0 to 12, this entire graph just becomes positive. It looks like that instead of what it looks like here. So by doing that, all you have to do is this, which is positive now, this, which becomes positive, and this. So you just have to add those up. So based on the graph, it's a little tiny there, but you should have it like on your front page. I can tell that the first shape is a triangle, so with a base of 4 and a height of 4, plus another triangle, which is now positive based on this image, and that is the absolute value velocity. That's a base of, what's the 1/2? A base of 4, and then that's a height of 2, plus a semicircle, which means that there's a 1/2, because it's half of a circle, pi r squared. And our r, it looks like it's 1 unit, 2 units, so it's 2. And then all we would have to do is just add those up. I think, no, honestly, you don't have to add that up, but if you do, it ends up coming out to be 12 plus 2 pi, and then do not forget the meter, because it said units, because it tells you to answer with units. And remember, this is total distance, so what would the units be if velocity is meters per second? Julia?
Meters per second. It's an
It's an integral. So how do you go down from meters per second?
Just meters.
Yeah. So just make sure to write meters.
So this problem was finding the areas of the triangles and the semicircles of the graph.
Yes. Plus, you need to interpret it. So that's the first part. That's the, as it says right here in the little corner, it says find that value. But then you also have to, interpret it like it says right here. So that's what we're going to do now. So I'm going to clear this. Julia, do you have it written down? You're good? Or are you still writing?
I'm good.
All right. So how to interpret this? So honestly, all you have to say is it's very simple, just like a one sentence thing. You say the integral from that, just write that down, is the total distance in meters, because it says with units. And then you also have to mention the two bounds from time t is equal to 0 to t is equal to 12, and then it was seconds. So then that's all you would have to write. And then that's pretty much that problem. The next few are kind of just like visual problems. So let's go to part C. Oops, part C. Now these are more just this is just very straight math. So let's just plug them in because it's 4 in total. So let's just solve them. So g of 12. So g of 12, we're going to use this little thing right here. It's the integral from 4 to 12 of f of t dt. And now this is just pretty much like doing the area under the curve. So it starts here and it goes here. Now these are all negative, so I'm just going to add a negative in the front just so I don't forget it. And it's the same concept as we did before. It's a triangle, so that's 1/2 times 4 times 2 plus a semicircle, which is 1/2 pi, and that's an r squared, so it's 2 squared. And the negative in the front kind of just ensures that I don't forget that it's really negative. And that would be correct, but when you simplify it, it ends up being -4 minus 2 pi, and that's how you do it. So now moving on to g of -3.
Also,
All you have to do, yeah?
why do you have the negative there?
Well, because we're not doing, now we're just taking the area here. Before, we would have to flip it over like this, since it asks for the absolute value, but now it doesn't. So since it's under the curve, it's negative. And really, you can just put a negative in the front of both. So you don't have to write it like that. You can write it as, with like a negative here, just negative, if that makes more sense to you. But yeah, it's the same thing. It's just that since it's under, it's negative. It's simple. So now to g of -3. G of -3 is going to be found with the same formula right here. So it's from 4 to -3 f of t dt. But remember, whenever you're doing integrals, the lower number has to be here, and -3 is on the top. So we have to rewrite it as in the correct math grammar, I would say. So it becomes whenever you have to flip it, essentially, you just have to put a negative in the front. Remember that. So it's from -3 to 4, f of t dt. And then again, all we're going to be doing is adding up the shapes, essentially. So remember the negative in the front. I'm going to do the integral now. This negative is from right here. I'm just putting it here again, so I don't forget it. So now when we're adding up the shapes, it's from -3 to 4, so you have to do this little tiny one there, and then this big one here. So the area of the little tiny one, it looks like it has a base of 1. It's a triangle then, base of 1, and a height of 2. And remember that since it's under the graph, it's negative. So I'm going to put the negative on the 2. Plus the big triangle, and that has a base of 6, it seems. A base of 6, and then a height of 4. And that's your answer. That's all you have to write, but if you're wondering what it simplifies to, it's -11. But yeah, really all you have to do is write it this way if you don't want to make any mistakes. So now moving on to g prime of x. So I'm going to clear it again. G prime of x. I'm going to write g of x first. You guys need to know what g of x is to get to g prime. So this basically tests your knowledge of the second part of the fundamental theorem of calculus. So really, all you have to remember is when you're taking the derivative of an integral, you plug in, it's still upper minus lower, but you plug in your value there into here. You take the derivative of that value minus, and then it would be, you plug in the value and you take the derivative of the value, which is 0. And there's a very easy way to remember it. It just ends up being f of x. But that's like the full way to do it. If like you just want to memorize like one way. So really it's kind of this, but it really does simplify to that. And that's what you have to write. So that's g prime of x. And now all we have to do is solve for g prime of 4. So I'm just going to do it actually right here. G prime of 4 is f of 4, which all we have to do is look at the graph, and it tells us that it's right there. So that's 0, and that's the answer. Now, and I'm going a little fast, but now just to move on to part D, because this is a kind of like a longer question. All right. So it says, find the intervals when g of x is decreasing on the interval -3 to 12. Justify your answer. All right, so remember, how do we know if something is decreasing? We take the derivative and look at the sign of the derivative. Remember that if the sign is negative, then it must be decreasing. And if the sign is positive, then it must be increasing. Simple. So we already took the derivative in the first problem. We got that g prime of x was equal to f of x. So now all you have to do is see where f of x is negative and then write that. So, and wherever f of x is negative, that's going to be where g of x is decreasing. So, Julia, can you tell me where g of where it's decreasing, where f of x is decreasing? Or negative. I'm so sorry. That's what I meant. Where g prime of x, which is equal to f, is negative, because it's asking when it's decreasing. So it's this little one right here.
Okay, so it's like at -3. That's
Yes.
Are you asking?
2.
Okay, -3 to -2.
Okay. Next.
From 4 to 8. No.
Yep. That's a good point to make out. Like, I guess that it is from 4 to 12, but since it kind of like reaches 0 there, like sometimes they like you just to like write it like that, like kind of acknowledge the part when it goes to 0, like where it's almost about to be positive, but then it just keeps saying negative. But either way is right. So if you write it like this, it would be perfect. So then all you'd have to write is basically what we just said right here. Just put it into words. So you could just say g of x is decreasing on -3 to -2, 4 to 8, and 8 to 12, since, and this is also kind of important, since g prime of x, which is equal to f of x, show that you know that you're referencing this graph by writing it that way, is negative on these intervals, and that's all you would have to write. So now to move on to part E. Julia, do you have it written down?
No, not yet.
Oh.
All right, let me know.
Let's say we're running out of time and we're doing like one of our last questions on the test. If she said that you could like circle something and then point to it, right, instead of rewriting it, like would that considerably be allowed?
I feel like, well, because it might be a little hard to circle something, only because like we're not gonna have it printed, but I guess since, like, if you are running out of time, just do that. Like, really, like, if you like kind of did it in your head at first, like how you planned it out first, and you just want to circle it, just like literally draw the line and do that.
Well,
Like,
I was thinking, like, let's say you got the 3 intervals, right? Like the way you wrote it out. If you like put a circle around those 3 intervals, and then you say since, or you'll say G prime or G is decreasing on, and then point to those intervals because, and then you write the rest of the thing.
Yeah, that would be perfect. That would be perfect. I feel like they would even kind of like, remember how we kind of planned it out at first and said like, oh, G prime, when it's negative, it's decreasing. If you literally like just like drew like a circle and then connected it to this one right here, like I think they may even accept that.
Okay.
Don't take my word for it, but if you're running out of time, do that. Like, do it, because it's better that you just circle what you want and write the answer than like miss out on getting points.
Okay.
So now moving on to the next one. Similar, but now it's asking for concavity. So find the intervals when g of x is concave down on the interval -3 to 12. So you guys know that concavity is normally determined by the second derivative, but there's also a way to determine it with the first derivative, only because the second derivative is the graph of f prime of x, and we don't have that, and I wouldn't want to assume anything from looking at the graph, so I'm going to use this right here. And we know, again, that g prime of x, from g prime of x, we know that g is concave down when g prime of x is decreasing, and concave up when g prime of x is increasing. So by that logic, let me clear this part right here, just so I can write it the correct way. Natalie, where do you see that it's decreasing? And then that would be the answer.
For
You guys
G
remember?
X, okay, then it would just be from, I can barely see this numbers, but 0 to, I think that says 6.
Yeah.
And then from 8 to about 10.
Yeah, that would be the answer. So then all you guys would have to say is g of x is concave down on 0 to 6 and 8 to 10, since g prime of x is equal to f of x. Remember to show that you're looking at this graph is decreasing on these intervals. And then that's all you have to do. Again, I would say these actually might be a little too simple for this AP test, but they're good practice, and I can assure you that like at least 3 out of maybe the 6 parts, 3 or 4 of them will be as simple as that, only because like there's always easier parts and then there's always the harder parts, of course. And I think part F kind of goes to that harder logic, so let's kind of try to attack that problem. So let me clear this and do part F. Now it's kind of going to the second derivative that we are hesitant to go to, since we don't have, remember the second derivative is the graph, it's the graph of f prime of x, but we don't have that. So it says to find g prime of 4 and g prime of 6, or state y does not exist. So basically we have to do g prime of 4 and then g double prime of 6. Let's do this one first. So from this logic, g double prime of 4 is equal to f prime of 4. If we look at the graph, f lies like on this little segment. So all we'd have to do is take the slope of that segment, because it's asking for f prime of 4, and we know that slope is the derivative as it's indicating. So, and we kind of did it earlier, it's like just -1, -1, -1, -1. So it's -1 over 1, which means that g double prime of 4 is equal to -1. So that one wasn't too bad. But now it says find g double prime of 6. 6 is right here. Notice how it doesn't really lie on one line point, or one, like, notice how it doesn't lie like on this line. Let me make it more clear. On this line or even this line. So you just kind of have to specify, you have to find a way to find that answer without using the line method that you've been doing like prior to that. So basically what Ms. Q recommends that we do for this, and I'm gonna clear it only because it's like a much longer process than I would initially like to do. So this kind of goes back to like one of the first few lessons that we did in the year, and it's just the definition of a derivative. And if you remember, the definition of a derivative is the limit as x approaches that certain number, and I'm gonna call it, let's say we're gonna call it u. So the definition of the derivative would just be f of x minus f of u over x minus u. And that's kind of like what the definition is. And since limits are fairly easy to find, that's, I think, the best way to do it. So with this problem, the derivative would follow the same logic by even though we're doing the second derivative. So for this problem, for example, since we're doing we're trying to find g double prime. In order to find it, it would be the limit as x approaches u of f prime of x minus f prime of u over x minus u. Because really, you have to kind of go, like, for at least little part right here, you have to go kind of what's under it. So the second derivative would just be this, pretty much. And now that I feel like that's the best way to show the double prime of 6. So let me know. Does that kind of make sense? Julia, Natalie, anyone?
Kind of.
Kind of.
Wouldn't the derivative at 6 not exist because it's a sharp point?
Yes, and that's exactly what, like, we already know that it doesn't exist, so you can be expecting that answer, but it's not enough just to say that. You have to prove.
Say it?
You can say it, but then, I mean, I guess you can say it, but then you might not get the full credit, only because, like, why doesn't it exist at a sharp point?
I thought it was like a rule.
It's not a rule, essentially, and I think that Miss Q said it one time that, yeah, of course, since it is a sharp point, it will not exist. But like, you kind of need to explain why it doesn't exist at a sharp point. And remember, like, whenever like there's an absolute value, like, it's really just because, like, remember, absolute values are kind of like the sharp point, as Miss Q described. And the reason why they don't exist is because of the fact that the limit here, the left, is not the same as the limit to the right. And that's kind of where we're getting to. So I get that this process it's kind of more lengthy than people would like, and I'm gonna try to explain it to the best of my ability. And Miss Q said that you wouldn't get a full credit if you just say the sharp point. That is not enough. So I'm gonna teach you guys the way that, like, the most theorem-based way to do it. So just remember that we're trying to find it at 6. So g double prime of 6 has to be equal to the limit as x approaches 6 of g prime of 6 minus g g prime of x minus g prime of 6 minus x minus 6, which as we know from this equation right here, just because we're going to be using the graph of f, it really just ends up being that g double prime of 6 is equal to the limit as x approaches 6 of f of x minus f of 6 over x minus 6. And this is like one of those like harder problems, I would say, like would be on the test. So try like your best to like follow along. But again, if you don't, remember you don't need all the points to pass. But like try really do it. Like if you have any questions, just ask me, because I know this is like more it's harder to understand. It's much harder to grasp. So now to go to this. How do we know if the limit exists, right? Basically, the limit from the left has to be equal to the limit from the right. So that's what we're going to do. We're going to take the limit from the left, take the limit from the right, and see if they exist. No, which, as Natalie said, since there's a sharp point, we already kind of know the answer, but we need to prove it. So I'm going to do the limit as x approaches 6 to the left first, which is f of x minus f of 6, x minus 6. So let's plug in what we know. F of 6 is -2, right? We can just tell that from the graph. And then x minus 6 stays the same. But what is f of x, right? F of x, at least when you're looking at it from the left, is this line. That's what it is. And any line can be defined by a function, if that makes sense. Or any line can be defined by an equation of the line, kind of, right? Does that make sense? So what I'm going to do is write an equation of the line for this segment. And what I'm going to do is plug it in right here into this little star once I get it. So what is the equation of this line? Well, all we need to know is the point and the slope. So we already did this several times. We got that the slope of this line was -1 over 1, -1 over 1, -1 over 1, just by doing like the rise over run. And we get that the slope is -1. So our m is -1, but then a point. You can use any point on this line if you want to do it. But I suggest using a point where one of the coordinates is already 0, just because when you do it, when you plug it into point slope form, you know, it's easier when one of these little minuses ends up being 0. So I see, let's do 4, 0. That's one of the points on the line, this one. So I'm gonna put a 0 here, a 4 there, and this becomes -x plus 4. Now we can write it here, -x plus 4. And now you can kind of start to see how this is different from this line segment, because this one is clearly decreasing and that one's increasing. So it's clearly going to cause like a rift in what this limit is equal to, and then what the limit from the right is equal to, if that makes sense. And that's kind of like the math logic behind it. So how do we solve for this? So my method, when you're solving for limits like that look like this, you kind of want the top to equal to in some way look like what's here on the bottom, so you can cancel those out, and then you'll get a number. So this, when you add those up, my pen is not working. When you add those up, you get that -x, and that becomes +2, so it's +6 is equal to x minus 6. And if you notice, those are almost the same as one another, except that you would have to rewrite this as, I'm gonna write it over here. Remember, you have to keep writing limit until you plug something in or cancel something out. So that's why I'm writing limit over and over again. So it becomes like this. And what I'm gonna do is factor out a -1. So this looks like this, and this looks like that. And if you see, those cancel. So then all you're left with is -1. So from the left, it equals -1. And that's all the work for the first part. And now we have to do it for the right. I know this seems like super tedious and super long, but it is kind of the best way to prove the answer. And this could really be like the last part of the question because it's that hard and that long. So for the next part, similar logic, but now all we're going to be doing, every minus that we did, so I'm going to erase this, because it pretty much is the same thing. Then you have to write all of that. And now, and that's all bad. It's from the old part. Now, what we're going to do is do it from the left. This line segment. So this becomes a plus, this becomes a plus, that becomes a plus. And now, when we were writing this, our f of x is going to be a little different because as you guys can see, this is a line going up. So to find that, let's plug in what we know first. So we know f of 6 stays -2. X minus 6 stay the same. And now we have this line. So this, I'm going to do the same thing. Rise over run, rise over run. M is equal to 1 because that's 1 over 1 based on your graph. And the point, I'm going to use 8, 0. And then when I do this, it becomes y minus 0 is equal to x. Y minus 0 is equal to 1, x minus 8, which means that y is equal to x minus 8. I'm going to plug it in here. I got my pen. Plug it in here, x minus 8. And that simplifies to x minus 6 over x minus 6 because this becomes plus, and you're left with 1 because anything over itself is 1. So now just to wrap everything up, we got that the limit from the left with the little minus was equal to -1. The limit from the right with a little plus is equal to 1. So, and this is how you would say it. Since the limit as x approaches 6 to the left of f of x minus f of 6 over x minus 6, which is equal to -1, is not equal to the limit x of x. Let's write the same thing over again. It's basically this. Since they're not equal to each other, g double prime of 6 must not exist. And that's the full, complete way to get all the points with that problem. And that is basically what you would have to do, only because, that it's just what the rubric requires, at least for that problem. So unfortunately, it is long. I get it. I was tired doing that problem, but that is the correct way to do it. And that if you do want all your points, that's how you do it. So it's 4:53. I get it, you guys can't want to leave, so if you do, that's fine. But I do want to do this last problem only because Miss Q didn't go over motion as much as the other topics. That was the first week we were doing it. We didn't have to do homework for that week. So this is one that I picked out that was kind of interesting. And it's more logic based. So let's see how we do with that. So it says Karen, and this is 2009 Q1. It says Karen rides her bicycle along a straight road from home to school, starting at home at time is equal to 0 minutes and arriving at school at time is equal to 12 minutes. So during the time interval from 0 to 12 minutes, her velocity in miles per minute, it's always good to know the unit of measure. So I always like to highlight that. Is modeled by the piecewise linear function whose graph is shown above. So this is v of t. That's your velocity. Find the acceleration of Karen's bicycle at t is equal to 7.5 minutes and indicate units of measure. All right, so as we know from PVA, acceleration is the derivative of velocity. So in order to find a of 7.5, 10, we need to know v prime of 7.5. And how do we know v prime of 7.5? Well, we go to 7.5, which is here, and take the slope. So Julia, are you still there?
Yeah.
All right, so what is the slope of that line? Or like, what can you write to show that it's the slope of the line?
Isn't it -1?
Look closely at the units that are here. It's not in ones, if that makes sense. So you're gonna it's by 0.1. So well, you can do rise over run, but really like the best way to do it is to use this point right here and this point right there. And those points are 7, 0.3. Notice the units that are there, and 8, 0.2. And we can just do y2 minus y1. I always like to use these points when it's not as obvious. And since these are like in increments that we're not used to, I might be better to use the points. So by using y2 minus y1, we do 0.3 minus 0.2 over, and that should be 7 minus 8, which is 0.1 over -1, which is -0.1. But we're forgetting the unit. So Julia, what would be the unit for acceleration in this problem?
Miles per minute squared.
Perfect. So all you have to do is write that. So miles per minute squared, and that would be the answer for part A. So, and that's all you have to do. So to move on to part B.
I have a question.
Oh yeah, sure. What's up?
Why isn't it 0.2 minus 0.3?
Well, you could actually do the same thing, and you'd get the same answer. So let's just do that really quickly and see what we get. If we choose 0.2 as our y1, right, because we're doing y2 minus y1, so we choose 0.2 as our y2 minus 0.3 as our y1, this now becomes our x2, and this now becomes our x1. So it's 8 minus 7. 8 minus 7, which means this becomes negative 0.1, and this becomes positive 1, and you get the same answer. Does that make sense?
Yeah.
So you can use any 2 points, and you'll get the same thing. So just choose whatever you want. Now moving on to part B. Using correct units, explain the meaning of 0 to 12, and we did a problem just like this. Of the integral from 0 to 12 of v of t dt in terms of Karen's strip. So Julia, I want you to tell me exactly what words you would write to explain the meaning of this. I want you to write it for me. You can do it. Julia.
Me on the spot.
Do it. Come on, you can do this. You can do it.
Okay, wait. So integral of v of t, so that would just be miles, right? Just for starters.
It is in miles, but it doesn't just represent miles. It has a specific name.
Or whatever. Okay, so integral of 0 to 12, absolute value v of t
Is
I don't know.
If you want, like Natalie can help you or someone like that if you want.
Natalie, help me. Is what? And then I'll try and do the rest.
Is the total distance.
Correct. Okay, but it's the total distance of what? Of who? Of what? Like, you need to specify.
Karen's trip from T0 to T12 minutes. Why is it total distance? Because of the speed equals absolute velocity or something, and that means total distance when it's the integral?
That's like the logic, but you can always just remember total distance. It's a formula. It's like actually a formula in the Smart Book. It's the total distance is equal to, it's literally just the integral of the absolute value of velocity. It's like a formula. So if you just remember that formula, you know like what it is. My pen is not working too well, but that's what it is. So you said it's the total distance of Karen's trip. Can you continue it for me? I didn't hear you.
From T equals 0 to T equals 12 minutes.
In what units? Because it says with correct units. So we need to say what this is. And you said it really at the beginning before you even said anything. What's the unit of this?
Miles.
Correct. Make sure you write all of that because that's how they give you all your points. And you know it. You said it to me. So just make sure you put it on the paper just so you don't forget it and get all your points. So that's the interpretation. Now it says to solve it. So basically, what we're going to do is what we've been doing since the first problem. And all you need to do is remember that when you're doing the absolute value velocity, you just have to make all the negatives positive. The only negative is this little thing here. So this just becomes positive. And that's all you have to do. Now, what you do is you take the area of all those shapes. This is like a little more complicated. Well, because I don't know. I kind of saw it as like several shapes. Like I saw this as a trapezoid. I saw this as another trapezoid. Correct me if I'm wrong. I'm maybe seeing it in too many shapes. Like, do you see how many different shapes I see it as? Yeah. So you have to pretty much take the area of all those shapes, which I do think you guys know how to do. But let's practice with it. At least tell me what measurements you would write. So Julia, actually, Caitlin, let's see if she's still listening. Kate, are you there?
I'm here.
Good. Okay, so I want you to tell me the area of every single shape.
Okay,
Like,
wait.
go in order for me.
Okay, wait. Okay.
Like, just like tell me like what, like tell me the formula you would write for every shape. Like, just write it for me, and I'll like go. I'll write it as you say it.
Okay, for the first triangle, 1/2
Yes.
times 0.2.
Perfect. Next one.
For the second one, the same thing.
Yep. Perfect. I'm just gonna write. Yeah, I'll rewrite it. Next one.
For the trapezoid, okay, I always literally get mixed up with the trapezoid.
Remember, for the trapezoid, when you're doing like remember the formula is 1/2 like B1 plus B2 times H. Remember, the bases have to be parallel with one another. The bases have to be like two lines that never intersect. That's what they have to be. So, and the trapezoid, like one thing you have to remember is like the trapezoids, like they flip. This one is a little different from that one. So just remember that.
Is
So it's
it
1/2.
2 plus 1 times
Perfect.
3?
Perfect. Next one.
1/2. 1/2 2 plus 3 times 1.
2 plus 3 times 1. Wait.
Is it?
Are you talking about the green one?
Yeah.
I think it's 0.3 plus 0.
Oh, sorry. Yeah. 0.3. Sorry. Oh.
And then, yeah, the height is 1. Yeah, perfect. And then the last one.
The last one is 1/2 4 plus 3 times 0.2.
Okay, let me just double check. Sorry, lost. Yeah, that's perfect. 4 plus 3. And you can let me just see if like you need to add those up at one point, but no, you don't. So just leave it like that, and just remember to write miles at the end of it, just so that you know the unit. But leave it like that. That is the answer. Like, don't even bother simplifying because that can be long and it's too many things to simplify at once. So that's the answer to that problem. And I know, I don't know, like I see like too many shapes. Like maybe it can be broken down in a simpler way, but that's how I saw it. So like, I don't know. All right. Oh, Julia, did you have a question, or that was just like me hearing things?
I have a question.
Yeah, what's up?
Okay, so for the trapezoids between 5 and 8, how come for the first trapezoid we did like a base of 2 plus 1, but for the second trapezoid we kind of, instead of doing it from top to bottom, we did it from side to side and we used 0.3 to 0.2. Like it doesn't matter as long as you pick, like why?
It does. It does. Remember, the bases have to be parallel. So in this trapezoid, I'm gonna kind of draw it out here. And I'm gonna do from 5 to 7 and then 7 to 8. For this trapezoid, honestly, did you guys already write the bottom down just so I can clear it and make it more like visual? You have it all written down? I'm just gonna write it, draw it. So the first trapezoid, it looks like this. And the second trapezoid looks like this. I'm just breaking it down. In this case, this base and this base are parallel because if you draw lines, they never intersect, right? In this case, this one and this one are parallel. And that's why you're doing, this one is your B1 and B2 for this one. And then for the other one, you're doing this one, these two. Does that make sense?
Yeah.
That's like, you just have to visualize it like that because the bases always have to be parallel. That's the rule. So I don't know if that helps, but, and if you need to draw it like that, do it. Like just try to make, because you know the rules, you know the formulas. Like you just need to make sure that you're visualizing it the right way. So like, go and draw it on the paper. Like if you need a better picture of it, do it. Like go and do it. Just because you know the formulas, you know the work, don't risk losing points that you know you can get. So for part C, let me see if anyone can like kind of logic this one around. So shortly after leaving home, Karen realizes she left her calculus homework at home and she returns to get it. At what time does she turn around and go back home? Give a reason for your answer. So can anyone tell me when she changes her direction and goes back home?
Is it from 4 to 5?
No.
Is it from 8 to 11?
No.
Is it from 4?
2 to 3 or 2 to 4?
3 to 4?
Oh!
No.
2 to 4.
Yeah, why is it not 2 to 4 if she's going back?
From 2 to 4, yes, that is when she's going back. But like, it's asking which, at one point does she just, like, she goes and turns around? It's not the interval.
At 2?
Yes. Okay, it's 2. But why is it at 2?
That's like it goes from positive to negative.
Yes, that's exactly what it is. So since V goes from positive to negative, and I'm not going to write it out. So all you have to do is just use the stem of the question and say, she returns home, or she returns home at time is equal to 2. At what time does she turn around? So at time is equal to 2, Karen turns around to go back home since her velocity changes from positive to negative. But why is that true? Well, we're assuming that the positive direction is her way to school. So if she's traveling this way for V, and if she goes back home, she turns directions. So V would just be negative. And since V changes from positive to negative at t is equal to 2, that is like the reasoning behind it. She pretty much changes her direction at this point. Does that make sense?
Yes.
And it's easy to like mistake it for like, oh, like here, since it's going up and then down. And or like here, like you said, or here, like you said. I kind of interpret this little part right here as like the 1 minute it takes for her to get the calculus homework, because obviously her velocity is 0, she's not moving, she's in her home and she's getting her homework. That's what that is. And then here, like you said, that's like actually her velocity is constant, so she's riding at the same speed or velocity on her bike at that time. That's what it means. Does that make sense?
How do you know that like Well, it doesn't matter because that's not what the question's asking anyways. Never mind.
What?
That why do you, like, for example, from 4 to 5, isn't it also constant? Can't you be at the same speed from 4 to 5 as well?
Yeah, she is at the same speed, but it's just that really her bike isn't moving, so she's not moving. It is the same speed though. It's constant. You're right. You're 100% right.
Okay.
So like honestly, that's like a very like intuitive question, only because like it'll catch some people or just like they'll go through it too fast, and I feel like they may put something like that on the test, only because it requires no math whatsoever. It just requires an understanding of how velocity works on the graph. So
See, no math.
what?
This is what I like to see.
My God, of course you do. All right, so let's do the last part. All right, so Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function, I'm not gonna say it, or W of t is in miles per minute for 0 to 12 minutes. Who lives closer to school, Karen or Larry? Show the work that leads to your answer. So, how do we know who's closer? What do you guys think? Well, who's closer, it kind of depends on the distance they have to travel, right? Because if they're traveling a certain distance, then that's how far they have to travel to get from home to school. So that's kind of how we know how far apart they are. But can someone tell me if it's the total distance or just the distance? What would you do?
It's just the distance.
And do you know why? Well, at least let's look at Karen's case. If we did the total distance, remember we'd take this out, we do that. If we do that, we're accounting for her trip to school, and then her trip back home, and then her trip back to school. That's not the real distance of, the distance she has to travel. We're adding an extra little part here from her trip back home, which means that we're adding extra miles that are there in this case, but it's not the true for every case, only because she doesn't always go from school to home back to school. That's adding extra miles. Like, we're adding the part that she traveled back when really it's just a one-way trip. So that's why we're just doing the distance, because you need to understand this. When you're doing regular distance, when you're doing regular integrals, so when you're doing a regular integral, you need to notice that since these are the same shape, they would just cancel out. So really, that accidental trip she made and then went back to home for her calculus book, it doesn't matter. And when you're doing like a true integral, so just from 0 to 12 of v of t dt, really all that matters is the yellow part that I'm going to color in right here. Only because that's really her true distance, how far she is from the school. Because remember, this is when she's on her way there and realizes she forgot something, so she turns around and then travels this. But once you just do the regular integral, this and this cancel out, because really it kind of like disregards the fact that she made a mistake and had to travel back. So that's kind of like the logic behind that. Does that make sense?
Yeah.
It does? Okay. So really all I'm going to do is just take the integral. And the same can be said about Max, or whatever his name is, Larry. So let's just say that Larry did the same thing. And then like that's his graph. Let's just pretend that this is the same and this is the same. If that's true, those two would cancel out again. So what we're going to do is just take the integral from 0 to 12 of Larry's equation as well, which is W of t. And this is a calculator problem, so don't even bother integrating that.
I have a question.
So, yeah.
But then if Karen then started going back to school again starting at 5, why don't we take the integral from 5 to 12?
You can. And I think they would mark it correct. But it's just like, it's the same thing. It really is the same thing. You can do that. Let's actually do that, just because it's the same answer. And it just shows that you're like aware of the fact that that first part like really doesn't count. So let's do that. So again, this is like the trapezoids again. It's a lot, very lengthy. You guys already did that, so what I'm gonna do is just write it out for you, because you guys already went through the process of telling me those shapes. So I'm just gonna write it out. Those formulas end up being 1/2, 2 plus 1, 0.3. Oops. And then it becomes 1/2, 0.3 plus 0.2, times 1, and then 1/2. It's 4 plus 3 times 0.2, and then you're pretty much good. But now the last thing I would do in this case, and I know like Miss Q always said, oh, I think I exited out. I know Miss Q always said like you don't have to simplify it, but in this case I do think you do, only because if you notice, the question is asking you to compare how far they travel. So in order to compare, like, and again, when we do Larry's integral, we're probably gonna get a number too. But how do we know how big that number is compared to this if we don't simplify it? So I'm gonna do Larry's integral on a separate page. So let me just clear this. What I'm gonna do is just clear it on red equal sign, sorry. And you just have to simplify that just so you know really what it is. And I'm gonna tell you what it is only because I don't want to take any more of your time. That ends up simplifying to 1.4 miles. And all you have to do now is put Larry's integral into the calculator. So we're just gonna practice with that, and then just someone tell me what the answer they get, and I'll confirm. So all you have to do is do the integral from 0 to 12 of w of t dt in your calculator, and then let me know what you get. And remember to write the units. Did anyone get an answer already?
I'm doing it.
All right, let me know.
$1.6.
Correct. So his distance is 1.6 miles. So Julia, tell me, who lives closer, Karen or Larry?
Karen.
All right. And then all you have to do is say, Karen, just say like by the work above, because all that work just shows your answer. Karen lives closer to school. And that's it. That is like a very, like, out of all the motion problems I read, and I read most of them, I feel like something like this is what they would put, because again, it's very minimal math except for this, which is even more math theory versus just math, because it's asking you to know that the integral velocity is the distance from a certain location. So I do think that they would put something like that. I feel like they may put something again with the remember the g double prime of 6. That's very plausible. And I just want to make sure that you guys are prepared for like all the scenarios that they could give you on the test. This is our last session that we're going to be doing, because as you know, we do this on Tuesdays and Thursdays, and next Tuesday is the day of the test. So we're going to have to do the rest of our studying on our own, only because like we're all very busy at this point. But I really do think that all of you in this chat have the ability to pass this test like with flying colors. You know, Miss Q, all the practice, all the lessons Miss Q has put us through, they've all helped a lot. So I think that by doing these problems, by getting practice, and if you have any other questions, just text me on Remind and I'll help you, even if it's the day before the test. So just let me know. And that'll be the end of this session. So thank you guys for coming. Sorry for taking kind of long, and I hope it helped. So that's pretty much it.
Thank you.
Bye.
Bye.